Alright guys, so today we'll be talking about logarithmic equations from a graph or from two given points and a vertical asymptote. Remember, that's all you really need is your asymptote and 2 points. So if you remember from my last video, we talked about graphing from an equation. Okay, and so we have our formula here of log base 2 of x plus 1. Okay, and that was the equation that I graphed over here. And I had a point at 0, 0, and 1, 1. So we're just going to start with that equation since we already know what the graph looks like and what the equation should be. It should be pretty easy to check ourselves. So let's start off firstly by just remembering what our equation is for a log. Our big ol' formula with h's and k's. So you have f of x equals a, which is like your slope. We'll say our log base b of x minus our h plus our k. Okay, and so we'll start off firstly, and since we have our graph here and we already know what it's going to look like, it kind of gives us an idea, kind of just check as we go. Okay, so first off, we know that our h is always our vertical asymptote, so that's something we know, so that's where we can start. Well, my vertical asymptote is at -1, so if I plug in a -1 for h, that'll make it +1. So let's put a +1 there for h. Okay. Say log. I don't know this other stuff yet. We'll get there. Okay, well, I also have an ordered pair. I have an ordered pair at 1, 1. So that's an x and a y. So let's plug that in. 1 for x, 1 for y. Okay, now, if you remember, remember wherever my asymptote is, that's what makes my parentheses 0. Okay, because over here I have -1 plus 1 gives me 0. Okay, and the reason that my asymptote is there is because I can't have a 0 inside my parentheses. Okay, because remember this is 2 to the what power gives me x plus 1, and 2 to no power will ever give me 0. So that's why I have an asymptote there. Okay, so if that's the case, this is where my parentheses equals 0. And then remember when we set it equal to 1. Okay, when we set it equal to 1, it's x plus 1 equals 1. Okay, and that's what made my logarithm equal to 0. So whenever my logarithm equals 0, then my y-coordinate will just equal my k, because all of this will cancel out, and it'll just leave me with my k. So I will always have a point, either one to the right or one to the left of my vertical asymptote, because I'm going from either a -1, which makes that 0, to either a -2, which would take me to the left, which this isn't the case here, or a 0, which would take me 1 to the right and make my log 0. Okay, so that being the case, I know that my k value is this y value. It's the y value of where I'm at 1 away from my vertical asymptote. In this case, it's 0. So I'll say plus 0. And I'll show you that again on the next example of why that's true. Now, we're kind of just thinking about what makes this true. Okay, and so we're going to kind of be easy on ourselves here and say, well, 1 plus 1 equals 2. And if we remember what a log is, a log solves for an exponent. So one easy way to solve for our exponent is to make our base of our log equal to our parentheses. So 1 plus 1 is 2. So if I make my log base 2, well, 2 to the what power gives me 2? Well, 2 to the first power gives me 2. So this equals 1 if this is the case. And 1 plus 0 is 1. So that means 1 equals 1, which is a true statement. So since that's a true statement, that means I don't have a slope. I don't have to do anything to my a. So if we change this back to an equation, remember equations always have x's and f of x's. You always need to be able to plug in an input and get out an output. So I'm left with f of x equals log base 2 of x, remember that's my x, plus 1, and then plus 0, I don't really need to add that. So my equation is just log base 2 of x plus 1, which you can see is correct. Okay, so let's try one more. This time I don't have a graph, but I do have my points. I have a vertical asymptote at -4. This one's going to be pretty interesting. I have a point at -5, 2, and a point at -8, 4. Well, I'll write down my equation again, which is f of x equals a log base b of x minus h plus k. And my h value is always my vertical asymptote. So I'll say plus 4. My k is always the point, the y value of the point 1 away from my vertical asymptote. Well, -8 is more than 1 away from -4, but -5 is right next to -4. So my k then would be my y, which is a 2. So plus 2. Well, I have an xy pair at -8, 4. So I'll plug that in here. -8 and 4. All right, I have my log. And remember, my base is always going to be my parentheses added together. So I have -8 plus 4. Now the problem here is -8 plus 4 is -4. And I cannot have a base that is negative. Okay, that doesn't really work out with logs. We do everything we can to avoid that. So in that case, I'm going to kind of take the absolute value. So I'm going to put a +4 down here. And this tells me that I'm going to actually have to section off that negative. Okay, so I'm actually going to have to rewrite this as -8 plus 4, just like that. I don't take a negative away from my h value, okay, because my vertical asymptote is -4, so that still has to be plus 4. And just take the negative away from that 8. It's going to cross that out. It's going to end up looking like that in the final form. Okay, but I take the absolute value and make that a 4. Okay, now I look at this and I say, well, 4 to the, I'm going to make this a 4. So 4 to the what power gives me 4. Okay, and that's going to be a 1. All right, well, what plus 2 gives me 4? Well, obviously 2 plus 2 gives me 4. So to make this 1 equal to 2, I'm going to have to multiply it by 2. So I need to make my a 2. So if we write this back out, I will have f of x equals 2 log base 4 of negative x plus 4 plus 2. And so this is a correct answer. Okay, if I graph this, I will get the correct looking graph. But the further we get into talking about logarithms and solving for logs, we'll see that there's a law of logarithms. Okay, and one of those laws is that I can actually move this 2 up to an exponent up here. I'll show you what I'm talking about. If I have 2 log 4 of x, and let's say that equals e equals my exponent, I can say that this is the same thing as log base 4 of x squared equals e. And if we remember, this is my base, so I have 4 to the e equals x squared. And 4 is the same thing as 2 squared. So I can say 2 squared times e, remember multiply exponents, equals x squared. And I can cancel out my 2's. So 2 to the e that back to a logarithm, I end up with log base 2 of x equals e, which tells me that I can actually change this to f of x equals log base 2 of negative x plus 4 plus 2. Now these are both the same graph. This one down here is just a little bit more simplified, and one way to think about it a little bit easier is I can take my base and find the root, whatever this is, that's the root of this base. So I can take 4 and I can square root it to give me my new base of 2. But we'll get into that in more detail here later on.